Hello. Hey, Andrea, you made it.
Hello. Sorry.
Hi.
Thank you.
Oh, I better put my actual name. All right. I guess I shall start now. It is 5 o'clock. I see lots of familiar names, and especially from some people I haven't seen in a long time. When I used to be part of TAS until I kind of my job and stuff graduated me everywhere else for a while. Here's one more person. So hello, everyone. My name is Asis Gonzales. I am from the Santa Fe Children's Museum. My specialty is planets and moons. I studied planetary science at the University of New Mexico. I used to work at the New Mexico State Museum Planetarium with Jim Greenhouse. You may know him. And today we are going to be exploring our current night sky and then our solar system, especially the stuff we can see. And during the program, please feel free to ask questions. Just raise your hand. You have a virtual hand that you can raise during the presentations, especially if there's like something you want to see in particular. All right, let's get started. Started setting you all up on a third screen just in case you have any questions or whatnot. But here we are. Let's get started. So this right here is the sky over Albuquerque. And a lot of these programs, they show the sky a bit darker than it actually is. Yeah, it's about that dark. And you may start to be able to see at least 2 objects in the sky right now. That bright object over there is Venus. Venus is the brightest object in the night sky, basically, because it's a planet full of clouds made of sulfuric acid, which are very bright and very, very shiny. And on the other side of the sky right now, I guess not the other side, maybe halfway, the planet Jupiter is up there. You should actually be able to see it right now. Jupiter, and both Venus and Jupiter are very bright. They're almost as bright as it's like looking at a plane in the sky, except of course they don't move. Saturn is actually right there in between them, but Saturn is a bit, it's not as bright as these 2 planets, so it's harder to find. But as the sky gets darker, we'll actually be able to see it. But for right now, let's just go explore these planets. Should be the only thing. If you actually went outside right now, you'd really only be able to see Venus and Jupiter. So this is our very own planet, where we're standing on right now, the only planet with tacos. Now, Albuquerque is right there. You can tell because we have 2 big interstates. You have I-40 and I-25, and they make this big plus shape. And so that's how you can usually tell that's Albuquerque right there. So yeah, all those little yellow bits and pieces right there, those are all the city lights that you can see as it gets dark, because we humans are very, very scared of the dark. So we turn on all our lights at night, and we just moved into the shadow. So if you were to go to Australia right now, it'd be daytime. Look at that. There's Australia. There's Japan, the Philippines, Vietnam, China. Oh, it's morning in China. They're just waking up. Let's travel to the planets that we can see up in the sky. We're going to go to Venus. Back in the 50s, they didn't know Venus was hot. Nowadays we know, well, nowadays being since the 80s or the 70s, actually, we know that Venus is very hot. It is the hottest planet in our solar system. Even though it's not the closest to the sun, that's Mercury. So this is Venus right here. It's completely covered in clouds made out of sulfuric acid. So if you actually touch those clouds on Venus, they would burn your hands. They would turn all dark. You don't want to touch them. But before radar, they actually couldn't see beneath the clouds. And it wasn't until they sent the very first robot through Venus's clouds that we knew it was hot. In fact, the first robot never made it to the ground. It basically just melted in the air. Yep, that's a good point. I forgot to mention Venus is hotter than Mercury because Venus has an atmosphere. It's basically like a giant blanket. So on Mercury, when it turns to night, all the heat that's on Mercury just escapes out into space. But Venus has these clouds that just kind of keep the heat there, like a giant blanket. This is an actual picture of the surface of Venus. So it's taken by Venera 14. This robot that took this picture lasted 57 minutes before it melted. The ground on Venus looks yellow in this picture, but it's actually black. It is made of basalt, lava rock. So if you took away the clouds from Venus, Venus would just be like a black planet, just covered in basalt. It's very flat too. There are essentially only 2 mountains on Venus. It's about the same size as Earth. It's slightly smaller, So it's all these carbon dioxide clouds that would burn you. And the surface of Venus, by the way, the air is so heavy that it's almost like being underwater. Right where this robot is standing, the air of Venus is about 93 times heavier than the air of Earth. So you would actually be crushed by that air. And not only that, it's so heavy that the winds on the surface of Venus can only go up to 1 or 2 miles per hour. Whereas at higher altitudes where the clouds are, the clouds can go up to 300 miles per hour. But on the surface, they can't. It's just like a thick clouds. It's weird. All right, so what's the other planet we can see up in the sky right now? So this is looking towards the south. We can see Jupiter. Jupiter is very bright as well. So one way you can tell planets apart from other stars is planets don't really twinkle like stars do. When you look at a star, it's like it's turning on and off. It's like bleep, 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 bleep. But a planet, it'll remain relatively still. Some planets actually wobble a little bit, like the light from Venus kind of wobbles, but it doesn't turn off like a blink per se. All right, so let's travel to Jupiter, right over there in our sky. So we're going from Venus, second planet, the sun, to the fifth. You know, there is a day of the week named after Venus. Problem is, you have to know the Spanish word for that day of the week. Actually, Friday. In Spanish, it's Viernes. It's named after Venus, but the English name Friday is after Freya, the Norse goddess. And if you know your Norse mythology, even if you've never heard of Norse mythology, you've heard of some of the characters like Thor or Odin. In fact, Thursday is named after Thor, Thor's Day. Although in Spanish, Thursday is Jueves. So in fact, Thursday, the Spanish word is after Jupiter. But in English, the Thor's Day is after Thor. And that's Jupiter. Although apparently, if you look at Jupiter right now, you wouldn't see the red spot. That's the funny thing about the old cosmic carnivals is we had the telescopes out and you can see the planets. Then again, you don't have this, these programs. Although I think we could have both next year. So if you want to see the red spot, we're going to have to move time forward a little bit. Jupiter spins pretty fast. It has like a 10-hour day. And right now, if you know what to look for, you notice that Jupiter is upside down. And so it looks like it's spinning backwards. But look at that, that's the red spot right there. And for people who look at Jupiter, the kind of misconception I want to get out of your heads is from far away, the clouds look flat, but they're not. It's just we're far away. If you actually were to land on Jupiter, say land near the edge of the red spot, you would have clouds, walls of clouds going miles and miles high, bigger than any mountains on Earth. And the walls of the red spot are moving at about 400 miles per hour, which is actually the slowest of the gas giants. And we'll get to those. We're going to travel to some other planets later, even ones that are not in the sky. Right now, we're just kind of going through what's in our sky. So the winds of the clouds of Jupiter are not these flat clouds. They're super tall clouds, and generally the white clouds are the tallest. Their chemicals being brought up by like updrafts, and the red clouds are usually the lowest, made from ammonia. So this is what it would look like if you studying another part of Jupiter. You'd have all these clouds of different layers, and we've never really directly seen lightning from Jupiter, but we've seen kind of like the flashes and the energy given out by the lightning on Jupiter. So that's Jupiter. I don't like it when it's upside down. There you go. Now it's not upside down. Jupiter has one of my favorite moons, and moons are, I think, sometimes way more interesting than the planets themselves, we're going to go to a moon called Io. Convenient. Sorry, there's an Io asteroid. And it always takes me there first before the actual moon itself. So let's go to Io. Moon. So Earth has one moon. Sometimes we have temporary moons. We actually, I think, just attained one for another 300 years. But Jupiter has 79. And actually, that number may have gone up recently. I think I forgot to check up on that. It's a number that goes up every once in a while. But this is Io. This is what I call the cheese moon, the queso moon, because it looks like a ball of cheese. Not only does it look like a ball of cheese, it is actually the stinkiest moon in the solar system. You see all those little black dots? Bloop, bloop, bloop. Those are all volcanoes. And the lava on Io turns yellow, green, and orange, depending on the amount of sulfur. Now, if you've never heard of sulfur before, sulfur smells like rotten eggs. So if you were standing on this moon, it would smell like rotten eggs. Yeah, the second moon is too small. And I like this moon. This is the fourth biggest moon in the solar system, I believe. Yes, ours is the fifth. And the green, by the way, if you don't know what that is, the green is pyrite. It's what they call fool's gold. You know, pyrite is made out of this combination of iron and sulfur. That's pyrite. From close, it looks kind of like, it's fake gold. They call it fool's gold. But from far away, it has kind of a greenish tint. Oh, we have a new person. Hello, new person. Since you just joined, we're visiting our moon. Sorry, not our moon, a moon of Jupiter called Io, which is very stinky moon because it's covered in sulfur and volcanoes. In fact, if you go to the night side, look at that. You can see all the glowing lava lakes. And Io is heated up by basically Jupiter's gravity and some of the gravity from other moons. It's being tugged at, pulled down on the inside, heating it up. Now, has it gotten any darker? Let's look outside. Yeah, a bit darker. You should actually be able to see Saturn now. Oh yeah, little tiny dot. That's Saturn right there. Saturn is pretty hard to find if you're not used to looking up at the stars and the different things in the night sky. In fact, right now, this program that's looking at the night sky is called Stellarium, and you can actually get this on your phone for free, and it's pretty good. And with the GPS, you can actually use it and look up at the sky, and it's showing you what you're looking at. So I would recommend Stellarium. There are quite a few others that are pretty good too. Google Sky used to be pretty bad, but I think they've gotten better. Oop, coming back in. So let's go to Saturn. So right now, these are kind of like the big three, the brightest planets in our sky. So let's go from Jupiter to Saturn. And look at that, there's our sun. Actually, before we get there, look at the sun. It lights up everything in the solar system. Whenever you see the face of Io being this green, yellow stuff, it's all lit up by the sun. Just like how we get light from the sun, every other world in our solar system gets light from the sun. But again, as you go further away, it just becomes less and less. Let's go to Saturn. Saturn has a day of the week named after it too. And Saturn is actually fairly easy to know which one it is. You know, it's everyone's favorite day of the week. In fact, it's right now, Saturn's Day. Tomorrow is even easier. I'm sure you can figure out what Sunday is named after. So this is Saturn. Saturn is what they call a gas giant. Now, gas giants are extremely strange. nothing in a gas giant works like it does on Earth. Things like solids, liquids, and stuff, those are all very different in gas giants. But the very simplest way to think of a gas giant, it's basically a planet made out of clouds. There are no mountains, there's no dirt, no valleys, no canyons, no caves. If you try to go to the surface of Saturn, it's basically just clouds. You'd fall. This is a painting, by the way. It's very difficult, almost impossible to actually take a picture of gas giants this close because of the intense winds. So the red spot on Jupiter was about 400 miles per hour. The winds of Saturn get up to 1,100 miles per hour. The second fastest in the solar system. The fastest winds are Neptune at 1,500 miles per hour. So these clouds are super fast. If you send like a spacecraft on there, it just get destroyed. So this is all clouds. You try to stand on it, on the surface, you would fall. And you'd fall for many hours. Just keep falling and falling and falling. Funny thing is you can't go through Saturn, even though it's made out of clouds. Because it's hard to think of it, but believe it or not, clouds have a weight. Right? They're made out of stuff. Clouds on Earth are made out of tiny water droplets. So the further and further down you go, the more and more clouds you have above you. And so the more and more clouds you have above you, the heavier and heavier and heavier they get. And at one point, the clouds would crush you. The easiest way to imagine this, one blanket isn't very heavy. But if you had 1 million blankets on top of you, well, then you would be crushed by blankets. A blanket planet would be so much more dense than Saturn. They say Saturn is so fluffy and so light that it would float in a bathtub. If you put it inside a giant bathtub, the funny thing is that that water would become its own planet with its own gravity. But of course, you don't care about the clouds so much. The rings are the important part of Saturn, the most famous part. I often get asked, why are they there? There's no real why, We'll get to that in a bit. Let's get closer. So first of all, it looks like a running track. You can get there, you can bring your gym bag, run, get a few miles in, a few millions. But as we get close, now to kind of slow down here because it's difficult. And in case you're curious, the program I'm using right now is called Space Engine. Went a little too fast. There we go. Look at that. The rings of Saturn are made of basically little bits of ice. Most of the ice in the rings of Saturn is about the size of a grain of sand. It'd be really difficult to run on those grains. It'll be kind of like going through a dust storm, but without air. Like that. That may be the worst description I've ever thought of. There's no hair, but it'd be like you're getting some ice in your face. There are bigger pieces, some the size of houses, some the size of boulders, but most of them is just little tiny grain-sized pieces of ice, just tiny ice cubes going around Saturn. And every little piece of ice cube goes around Saturn just like, the moon goes around the Earth. I'm not sure why the rings are there. They think it was a moon. So Saturn has a lot of icy moons, and they think it was a moon that got a bit too close to Saturn. It was just torn apart by Saturn's gravity. And then over time, they do kind of just get spread out. So Saturn is far away from the sun. Saturn has a lot of icy moons. Because it's far away from the sun, it gets colder. You get further away from the sun. And those lines in the rings, those are made by moons. In fact, let's go to one of those moons. It's called Pan. So we're going to this moon right there. It makes this line in the rings. And Pan, really the reason I brought you to this moon is because Pan looks like a little spaceship. Looks like some aliens were traveling through our solar system and they ran out of fuel and they had to leave their spaceship there and it froze over. It's pretty cold where Saturn is at. Pan is a very small moon. It's about 20 miles long. So it's like from the distance from here to Belen. I like Kaiser's descriptions. Yeah, it looks like kind of uncrustable. By the way, you can also talk to me in the chat. I forgot to mention that. If you don't want to actually like raise your hand or anything, you can ask me in the chat as well. I'm keeping an eye on that. But yeah, this is I love this moon. It's just a really funny looking moon. Pan, P-A-N, like bread in Spanish, but named after the Greek mythological figure. So it's small, and it probably got those ridges from scooping up the ice in the rings. The funny thing is Saturn actually has quite a few of these moons that are kind of UFO shaped. Well, that one's probably the most UFO shaped like moon. UF moon. No, it doesn't make sense. Now, Saturn has right now the most moons in the solar system. It has about 82. My favorite moon is around Saturn. It is called Encelades, which sounds like the Spanish word ensaladas, Spanish word for salads. Enceladus is covered in snow. That's actually not something common in the solar system. There's lots of ice in the solar system, but it's like hard ice, almost like a rock. This moon is covered in powdery snow. You would be able to go to this moon and you can have a snowball fight. You can make snow angels. You can make snowmen, You can do all that fun stuff on this moon. But I bet you're wondering, where does the snow come from? Because on Earth, snow comes down from the sky, The snow on this moon actually comes from the inside. So you know how Earth gets warmer as you go deeper inside? Well, so does these little icy moons. And this icy moon inside is warm enough that it has an ocean. How do we know it has an ocean? Well, you can see it. This is a picture of this moon from far away. You see that white plume right there? That is water leaking out of the moon. Like a broken hose from the inside. 400 gallons a second. It's not, well, that's a good question, actually. Let me elaborate on that. I need my pen. So basically, the water comes out I can't draw on this while it's on full screen. I can. Oh, shoot, I'm having a little glitch with this program. That's too bad. Oh, well, just won't use it. But basically, it comes out, and the gravity of this moon pulls it back down. So it comes out, and then it falls back down onto this moon. So it does snow upwards, at least here, but then it comes back down after shooting out from the... Why can't I draw? I wish I could draw. So this is what I call leaky moon, Enceladus. This is my favorite picture of Enceladus. It's yellow because it's getting the light from Saturn. Yeah, water comes out, it freezes, turns to snow, and most of it falls back down. What other physical aspects of this moon? It's very small. It is actually about the size of New Mexico. So this is Earth, this is our moon, that's Enceladus. And it has very little gravity, so you can jump very high on that moon. Or although you have to jump 200 miles per hour to get out of that moon. I don't think humans can jump 200 miles per hour. I feel like your legs would fall off. And one funny thing you can do sometimes is find out how much you weigh on different worlds. So you can actually find out how much you weigh on this moon, Enceladus, if you divide your weight by 86. So I'm very fat. I weigh 320 pounds. And if you divide my weight by 86, I would weigh about 4 pounds on Enceladus. You probably make, and I don't want to give you the idea that it's like an ice ball full of water. It'll probably more, it looks more like this. So there's a rocky core, and then around the rocky core where it's warm, there's the ocean, and there's the layer of ice, and then snow on the top. So they don't know why it only leaks on the bottom. Some people think there's a lot of volcanic activity on the South Poles that build up pressure, cause it to shoot out. I did a lot of Encelades today. So I was thinking, I'm gonna go somewhere you can't see in the sky right now. Actually, if we had a telescope on Saturn, you can see Encelades sometimes. It looks like a little tiny star. Titan over there, probably. So Saturn has all these moons. I think I'm going to take you to an exoplanet, just real quick. This exoplanet has a weird name. It's called 1 SWASP, J1407b. Try to say that 5 times fast. So we're going about 400 light years away. And just the concepts of distances in space is very difficult. So 1 light year is about 5.7 trillion miles. Our closest star, Proxima Centauri, is about 3.8 light years away, which makes it about 32 trillion miles away. It would take humans about 40,000 years to get there with our current technology. But let me see if I can give you an idea how big these numbers are. 1 million seconds is about 11 days. 1 billion seconds is about 31 years. 1 trillion seconds is about 33,000 years. So you imagine 1 trillion seconds ago, humans didn't have farming. So this planet we went to is quadrillions of miles away. And I'm not even here to talk much about this planet, actually. It's pretty big, twice the size of Jupiter, but weighs like 20 Jupiters. This planet has the biggest rings that we know of. In fact, the white you see here are the rings of this planet. Saturn's rings would only, they'd only go like up to here. So let's fly out and see how big these rings are. Now, these rings are different than Saturn's too. Saturn's rings are icy, sorry. What causes rings? That is a very good question. I will get to that actually after. But basically, it's the spinning of the planet and the spinning of stuff around it. I'll show you how in a bit. Just think of a pizza, right? Whenever you question something about astronomy, just think of food. There's usually an analogy there somewhere. So these rings are rockier and dustier than Saturn's. And the solar system that is here with these humongous rings, well, gravity helps, of course. Gravity helps keep the rings where they're at. So from the center to the edge, these rings are about 90 million miles. So if Earth had these rings, they would touch the sun. If Saturn had these rings, you would actually be able to see them up in the sky. And like Saturn's rings, they are flat as well. Look at that. And that happens as if things spin really fast. Let me show you something that kind of. So ever seen when they spin the pizza dough? Trying to find that video I have. There we go. Some people, I used to make pizzas, but I didn't do this. So you got the pizza dough and then you spin it. All right. So this started out as a ball of dough, but as you spin it, the spinning causes it to flatten out, become flat and bigger, right? The same thing happens to rings because rings are not very heavy. They don't have enough gravity to clump together as a ball. So the spinning causes it to kind of spread out. All right. Like that. I wonder if that pizza's like any good after he just like put it on his shirt everywhere. Did he eat those? So that's basically why you get rings. So let me see if I can draw it. Oh, I have a new person. No, I don't want an update. Skip. Let's see what my last class I was drawing. I guess nothing. Hello, new person. Sorry. I was asked why rings are flat. So I'm going to draw kind of why they are flat. So you get a ball of dough, and then you start to spin it. And so when you're spinning something, the insides are trying to kind of spread out like that. So as you keep spinning it, it spreads out even more. And then more. I hope that made sense. Called angular momentum. It is the same thing that actually leads to solar systems, because as a star is getting made, the star is spinning and the dust around it starts to get spun too, and it flattens out to these disks. And from those disks, you get planets. So it's kind of an important process. Just think of pizzas. Spinning pizzas. So that's the planet with the biggest rings that we know of. There's at least 33 rings. Ah, look at that. That's this planet's star, which is actually slightly smaller than our sun, slightly smaller. Let's go back to our Earth. I wonder what we can see on the night sky right now. It's gotten darker. Yeah, it's all. You just have the twilight out there. New person. And if you want to ask questions, just raise your hand or ask in the chat. Back to our Earth. Ooh, we moved even further, deeper. Actually, I think when we started, the light was still on California. Oh, no, that's because I made time go forward earlier. There we go. That's where we're at now. Let's look at Stellarium. Look at that. There's more stars now. This is actually about as good as it'll get for, being in Albuquerque. You'll see the 3 planets: Venus, Jupiter, and Saturn. And directly above you, I would actually look for this star up there called Vega. Vega will actually be your North Star in the year 14,000. Let's actually travel to Vega. I forgot I can do that. So Vega is about probably directly above you, somewhere in this direction. I'm gonna make a guess. It's this one. Wait, no, Vega's not that close to the Milky Way. Let's go to Vega. Nope, I was completely wrong. Ha. It's right there. So we're traveling to Vega, and if I remember correctly, Vega, let's see, the neb is about 2,600 light years away. Vega, I think, is about, oh my God, it's been so long. I think it's about 27 light years away. It is one of our closest stars. It is slightly bigger than our sun. I'm gonna find out. 25 light years away. It's been refined. One of the cool things about this star is it's shaped like an egg, because it spins really fast. Our sun, one spin of our sun takes about 27 days. And I think Vega spins like once every 12 hours. So it spins really fast, and it's kind of shaped like an egg. So here's the thing about stars. Vega, Deneb, and Altair. Yeah, those are the summer triangle stars. They're directly above you tonight. Maybe we'll visit all of them, actually. I usually talk about Vega. I haven't talked about the Vega and Altair in a long time. But stars are literally a ball of fire, right? Some people think stars are like lava, but they're not. They're so hot. They're too hot for lava. If you brought a bucket of lava from the earth and poured it on a star or the sun, the lava would just burn up like paper. And it would turn to something called plasma. But stars have also, even though they're all fire, they have all these weird like features too. So like if you get close to Vega, it's so bright. I don't even know you can see it. Look at that. It looks like it has little pieces of corn on the surface. Those are bubbles. Stars bubble. They're hot. That heat has to get out. I'm actually going to show you an actual video of the sun boiling. This is our sun boiling. Vega's a little too far to see this. This was taken by the Solar Parker probe. Look at that. It's very relaxing. This is a good video to show in a planetarium. It's really cool. I used to show this in my portable. Look at that. So stars bubble. Look at that. I'm wondering, Kai, did you have the Vega, Deneb, and Altair, the Chinese stories or the Greek stories? Because different cultures have different stories.
Jumped on it. What happened? I got the
Neither? Ooh. I wonder which one it is. Let me show you how big Vega is compared to the sun. Look at that. That's our sun. That's Vega, egg-shaped star. It's a fictional. Yeah, yeah. I know those stories are fictional. Our constellations are fictional. They're put up by humans, up in the sky. So Vega, there's Altair. There's Deneb.
So he's actually looking in the sky, the night sky. Here.
Yes, this program is to look at looking at the actual sky. The other one's kind of just like a 3D representation. Ooh, we have someone in the waiting room. Whoop. Yeah, there we go. So let's turn on the constellations. There's the Neb. I just needed to see the Swan. It's kind of hard to see that in my. I feel like I lost a lot of practice from looking at the night sky. But there's those three stars you mentioned: Deneb, Vega, and Altair. One of the, I think, the cool things about constellations is that there's basically thousands of them. Although we tend to focus just on the Greek constellations. But almost every culture had constellations. They're imaginary. That's a good thing. People told their stories or used the constellations as calendars. So these ones are the Greeks, thousands of years ago. I forgot which Stellarium. The Belarusians, I think, had a good ones. There you go. Look at those. Look at this. The Belarusian constellations. Actually, I should put up the names so you can read the titles. And what's really funny is how some different cultures from really far away all have like different, sometimes the same constellations a little bit. Like the Big Dipper is usually, that's the Little Dipper, is usually a wagon of some sort or a cart. Let's see. This program doesn't have a lot of art. The Burong had art. But these are from Australia, so we can't see as many of them. The Dakota here in North America, they had their own constellations too. Does this have Polynesian? Those are pretty cool. This does not have Polynesian. That's very sad. So the Greek constellations are not the only constellations. up in the sky. They were just very good at keeping records, so we have a lot of those still kind of memorized. Sorry about that spinning. So this is, again, just to clarify, this is looking towards the south. So Venus is in Sagittarius. Now, does that look like a centaur to you? I think it looks like a shrimp. And the teapot is a very famous asterism. You can see Saturn is in Capricorn and Jupiter is in Aquarius or close to it. Is there any requests? Anything you want to see before I go on? Or I usually just kind of go from the hip. Let's go further into the night. Actually, I do want to point out, if you know how to find, so inside the city, we really can't see the Milky Way. There's too much city lights. But if you find the Swan, Cygnus the Swan actually kind of points along the Milky Way. So that is a good way to know where the Milky Way is, even though you can't see it. So Cygnus the Swan. And when I started doing the, more stargazing, I would always find Vega first. And then Altair is usually a bright star. And then you can find Deneb. And that makes up the summer triangle. And tonight, again, they're like almost directly above you. So see if you can find these 3 stars tonight. That'll be my challenge for you. And that should be easy to find: Venus, Jupiter, and then Saturn is pretty hard. But again, if you get Stellarium, you shouldn't have any problem. All right, let's explore more of space. Let's go back to our solar system. I'm gonna go to Pluto. Actually, I think Pluto is in our sky right now, isn't it? Am I wrong about that? That's exoplanets. Planets. I thought Pluto was near Sagittarius at one point last year. Couldn't have gone that much further. I think I'm wrong. So this is Pluto. Let's talk about Pluto a little bit. So often I get asked, does Pluto still exist? It does. It didn't disappear. They just changed the category of thing it is, because sometimes we just discover more about our solar system and things change. And Pluto itself is a very, 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 very cool world. No pun intended. It's very wonderful. It's very beautiful. Look at that. It looks like a scoop of ice cream. It's covered in all sorts of different kinds of ices, especially that kind of brown stuff. It's called tholins. Tholins, think of it like frozen tar. This ice is soft and sticky. So if you were to step on this ice, it would go like squish, 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 and your foot would kind of stick to it a little bit. It is cool and cold. So actually, what I think would be really cool, it was the full moon yesterday, hence the eclipse. The moon will be up tonight, but fairly late. There we go. This is at 10:24 p.m. And it should still be really bright. But if you want to do this, so Pluto is so far from the sun that daytime on Pluto is as bright as a full moon on Earth. So if you're ever outside during the full moon, that's how bright daytime is on Pluto. So if you actually go out tonight, the moon should be bright enough that it will still be kind of bright as daytime on Pluto. So you can actually pretend you're on Pluto tonight if you're up late, or you can wait till the next full moon. It's especially and funner when it snows and you see this bright full moon, and then you can pretend you're on Pluto. Funnily enough, too, the sun will still hurt your eyes on Pluto. So it's as bright as a full moon, but it's more concentrated. It's smaller. So you still shouldn't look at the sun on Pluto. Just keep that in mind for when you go. And so there's like ice sand on Pluto. You know, sand made from ice. On Earth, sand is made out of pieces of dirt. Rock, not dirt. So. And over here, there are mountains on Pluto made out of water ice. And those mountains are bigger than any mountains on Earth. That's kind of one of the benefits of being a small world, because you have less gravity, you can have bigger mountains. Earth couldn't really have mountains this big because they would be too heavy. They would sink into the crust. Now, did you folks know that Pluto was not the first 9th planet? The first 9th planet was Ceres. So let's go back. Let's harken back to the late 1700s. It is always the most fun way to start a sentence. This chair is kind of squiggly. I hope you can't hear it. This is Ceres right here. So in the 1700s, they didn't know about the asteroid belt, but they used their math, and they looked at the position of the planets, and they were like, wait a minute, based on our calculations, there has to be something between Mars and Jupiter. And so they searched. And on January 1st, 1801, Giuseppe Piazzi discovered Ceres. And again, just to remind you, they didn't know about the asteroid belt. Yeah, so they were excited. Ceres was our first 9th planet, and they discovered another one, another one, another one, another one, another one, another one. By 1850, we had 24 planets. Do you imagine trying to memorize that? My very eager mother just sold us 9 nachos today. Everywhere, having fun today. Good now. It's a dwarf planet now. I need to find out what order they discovered it to make a new statement. So by 1850, we had 24 planets, but then they realized that, you know, these aren't actually planets. They're a lot smaller. They're actually more of a group. And so Ceres was no longer our 9th planet. It became an asteroid, which means star-like. The same thing happened to Pluto a bit differently, but it's the same process in a way. It's just slower because it's further away. It's basically the discovery of Eris. Eris is heavier than Pluto, slightly smaller by like 12 kilometers. And the debate became whether or not Pluto was its own thing. I mean, the debate as to whether Pluto was a planet has actually been going on since the 80s. And they decided it was a dwarf planet. And that's just what happens. People get mad, but, you know, that's just what happens. Actually, Ceres is a dwarf planet right now. And Ceres is really cool. I love Ceres. Ceres is covered in clay. Ceres would be very heavy. Not only that, Ceres has salt fields, like mud volcanoes, basically, on Ceres. So there actually may be a lot of salty, muddy water inside Ceres. There's clay on Ceres too, which you can only get with water, reactions with water. But, you know, these worlds are still wonderful whether or not they're planets. Let's go to Mars. How are y'all doing? And I used to talking to myself for this long. So thank you, Kai, for chatting with me. So this is Mars. Mars, the red planet, although it's, you know, not as red as people say. It's just covered in red dust, little very thin layer of red dust. Basically, Mars is, you know, if you just brushed off the red dust, Mars would be black. Mars is almost the crust of Mars is made of basalt. So basically, Mars has a black crust, and it's covered in just like this really thin red dust. It's just covered in the little red dust. So the red layer of Mars is actually very thin, and if you brushed it away, you would just see black. Yeah, it's rusty. So the red layer is actually very thin. It's like millimeters thick, and sometimes you see Mars. So if you see all these like dark splotches right there, that's actually the black lava rock that's underneath the red dust. So if you just brushed off the thin red dust, Mars would just be a black planet. It's kind of like Venus. Venus would be black if it didn't have all those yellow clouds on the top. Basalt is very common in the solar system. Look at that. There's Olympus Mons, the biggest volcano in the solar system. This volcano is so big that you can fit the whole state of New Mexico inside of it. It's so big that if you actually placed it on Earth, it would sink into the crust. And you can see lots of stuff around it, little wrinkles, from landslides, from icy, muddy landslides that used to happen around Mars. Because Mars at one point was covered in ice. Let's land on Mars. Ah, look at Mars. Looks kind of like New Mexico. Except there's no life, there are no plants. There's no animals, nothing. All Mars has is robots. Mars is the only planet only inhabited by robots, or rovers that we build and we sent to Mars because humans are, we need all this food and water, and our bodies start to fall apart in space. So we need to send robots right now until we kind of work that out. Mars, and this is Curiosity. I'm waiting for Perseverance to yeah, actually it does make sense. There comes a point where the bigger a planet, the more gravity, things just weigh more. Now, so Earth has big mountains, but yeah, some smaller worlds will have bigger mountains. Like the biggest cliff in the solar system is on a tiny moon, Miranda. Actually, we should go there next. So I think it makes sense. It's just the gravity. I mean, it's not impossible for Earth to have a big mountain like Olympus Mons. It's just a lot harder. So this is Curiosity. Curiosity comes equipped with cameras, lasers. Oh, it's an invisible laser. Can shoot rocks, tell what they're made out of, has drills, cameras, and it's powered by a nuclear battery, although it is on its butt. So I call it a nuclear battery. And then here is this, it looks like a soda can that's used to communicate with Earth. Actually, it communicates to a satellite around Mars, and then that signal goes back to Earth. But Curiosity did find a lot of evidence that Mars used to have water, liquid water. So there used to be lakes, at least lakes on Mars. We don't know if it was oceans. And it's just one of those kind of funny things. You need a lot to have water like we do on Earth. We have water on the top, all right? That's very rare. There's no other world in our solar system has water on the top. That's because water is very energetic. It doesn't want to stay in one place, essentially. So Mars, which is smaller, has less gravity. It couldn't hold on to its air and water that well. So it kind of just lost them over time. In its magnetic field. I'm kind of oversimplifying it. So I think I'm going to show you one last thing, unless there are any requests. But I actually thinking of how things have a bigger, I don't know if people are looking at the chat. Someone said, Kai said, does it make sense that Earth is bigger, so there are smaller mountains and Mars is smaller, but has bigger mountains? It does kind of make sense. But again, it doesn't mean that Earth can't have as big mountains as Mars. It's just a lot harder. One day when our crust just solidifies and becomes so hard, it may have bigger mountains, but then they're hard to make. We're going to stop by Uranus, which is how it is pronounced. In fact, if you wanted the original pronunciation is Uranus. Uranus, the god of the sky. Probably the least interesting planet in the solar system, but it's actually still fairly cool looking. You know, it's especially it spins sideways. Yeah, I think a lot of people know that. I'm going to show you how all the planets in the solar system spin. Sorry, I'm slowing down because I couldn't find the video. There we go. So this is the different rotations of all the planets. So Venus is upside down, by the way. So there's Earth and Mars, although Mars has an incredible wobble. Jupiter. So most planets, they rotate counterclockwise. That's against the clock. Pluto is sideways too. Neptune is tilted. So Uranus is on its side, rolling up and down instead of sideways. A lot of that probably has to do when the solar system was first made. There were a lot more rocks and extra planets, but there were probably more planets back then, and so there's a lot of evidence for many worlds having big impacts. But the bigger worlds like Jupiter and Saturn, because they were so big, they probably weren't as affected as some other worlds. But that's Uranus, the little sideways planet. It has a moon called Miranda. Miranda has the biggest cliffs in the solar system. Called Verona rupees. I don't know if it's pronounced rupees or rupes. Any of you task members know? I've always wondered about that. So if you look at right there, these cliffs are 12 miles high. Oh, Kai, did you have your hand up? I didn't notice until now. Have you had it up for a while? I hope not. If you were to put yeah, sorry, did you still have a question?
So basically, Uranus's North Pole is always in nighttime. And the South Pole is always in day.
You're close. I think the day, I think it has a 50-year day.
Jeez.
I think. Yeah, I think it just has because as it goes around the sun, the part that was facing away from the sun will face the sun as it gets to the other side, you know? So it just has like a 50-year day, I think.
Okay, thank you.
Sure. Sorry, I didn't see your hand up earlier.
It's okay.
So these are the cliffs of Verona rupees. If you were to put them where the Sandia Mountains are, that's how tall they would be. They would go, you know, that many times above the Sandia Mountains. And I said it because I forgot how many times. And I did the calculations before. But the fun thing is, Miranda doesn't have as much gravity as Earth. So you could actually jump off of these cliffs. It would take you about 12 minutes to fall down. And if you landed on a pile of pillows, you'd be fine. Whereas on Earth, you'd hurt yourself quite a bit. And I think I'm gonna end it by showing you how fast, how differently things fall across the solar system. All right. So let's pretend that we're taking a ball and we're just dropping it towards each planet, each world, from about a kilometer high, right? And this is actually how fast it falls on each world. So look at the sun. Then it fell down and it burned up. Look at Jupiter. Neptune. So you notice Earth beat Uranus. Uranus, even though it's bigger, Earth actually has more gravity than Uranus because Earth is denser. Look at the moon is still going. This video is from James O'Donoghue, Dr. James O'Donoghue, and he makes lots of good videos like this on his Twitter and YouTube channel. Let's just stare at Ceres. Look at Ceres. It's a little gravity. It's still falling, and that's also kind of what happens in worlds with less gravity. It's not, you don't get, it doesn't pull you down as much, but it's also slower. All right. So like one of the things, like when you go to the moon, you have to walk slower because if you move too fast, you can kind of launch yourself a little bit if you're not careful. And then finally, look at that. Whew. And finally landed on Ceres. But all right, I think I'll end it there unless there is something you want to see. So just remember to go outside and see if you can see at least, find Jupiter and Venus because they're incredibly beautiful and they're just great. I wish there was a safe way to look through telescopes right now to have telescopes out. Keep thinking about like glasses and stuff like that, but it's pretty hard because I just want to show people Saturn. It's up right now. And if you're out in the full moon, just remember that's how bright daytime is on Pluto. So you can pretend you're on Pluto. And I think I'll stop right here. Thank you very much for joining me today. I hope you had fun.
Thank you.
And I'd like to say you're welcome. Have a very good night.
You too.
And I'll see you around. Bye. Au revoir. Auf Wiedersehen. Aloha. Can't think of any other word. And I'll send you the link to the recording once it's done. And Andrea, this is actually, I couldn't find any other like pre-kinder or even first grade classes that I'm doing at the rest of the year. But if I get one, I'll let you know. Have a good evening.